Okay, so we begin with this additional law. The additional law says the probability of the union of A or B is equal to the probability of event A plus the probability of event B minus the probability of A intersection with B. So let's have a very quick example here. So I'm going to move this back up here. So in this case, we have some employees in a company with different blood types recorded, and we're going to pick one person. And what's the probability that that person is either a male or the person's blood type is 0, okay? Now if I let the event A to be the event that a male employee is selected, okay? And as you can see, these 4 are the possibilities, right? And if I let event B to be the event that the employee's blood type is O, so that is these 2 possibilities, right? So if you can take a look at the formula, then very easily you can tell that is the probability of male, that is the total number of males over the total number of employees, plus the probability of blood type O, that is 4 plus 1 over 20. And finally, you have, because there's an overlap, you don't want to double count it, so you have to subtract it by the overlap, this part. That is this, which is 4 over 20. So it's pretty easy. So this one is a more standard question. And so 2 computers are used to generate a number each. Computer X could generate randomly a number from 2, 3, 5, 6, and 7. And Y can generate a number from 2, 3, 4, 5, 6, and 7 at random. So we have one number from each computer. So find the probability that the 2 numbers multiply together to give 12, or at least one of these 2 numbers is an odd number. So this is what we can use a table, just like the previous example, to do. So here's a table. It's a 2-dimensional table, but here's a note that all these boxes or combinations of 2 numbers are equally likely to happen, okay? So they have the same probability for each, okay? And otherwise, then you have to use a tree diagram. So here we go. Let A be the event that the product of 2 numbers is 12. All right. So we have this one, we have this one, and we have this one. I believe that's it. And let the event B be the event that at least one odd number is obtained. Okay, so odd number, at least one odd number. So we have this and these and these, and also these and these. And so the required probability would be 3 over 30, the green ones, plus 24 over 30, the yellow ones, minus the intersection, okay, the overlap, which is only this one, right? Okay, so that's just 1. And so the answer would be 13 over 15.